And with exponent rules, it's important to remember that there are a lot of different ways these can be done. Okay, so here I've kind of outlined the main rules for exponents. If we have exponents, essentially are counting, multiplication, and division. So if I multiply two exponents of the same base, so the same multiplier, I count that multiplier together. So I add a plus b. If I divide, we count the multiplication against the subtraction, or we take away the number of times we divide by x from the times we multiply by x, so we subtract the exponents. For power to the power, here we have basically the base of x to the power a. That means we have b groups of this. That means that I have b groups of a, so I then multiply a times b. The exponents can multiply each other here. And so these are the main rules, and as long as we follow these main rules, we should be okay. So there's a few different ways we can do these problems. So I'm going to show you a couple different ways. So typically we like to work inside out, and the first strategy I'm going to use is I'm just going to apply the exponent rules, and I'm going to apply the exponent rules from inside out. So inside out is typically the easiest, but that means that we have to keep track of all the stuff that doesn't get done. So here I'm going to apply the exponent -3 as a power rule. So power to power, we multiply those exponents. So I get -6. Power 5 to power -3 is going to be -15. Here we have, we're multiplying with the same base, so I'm going to add these exponents together. I'm going to count these divides against this one multiply, so I'm going to end up with x to the power -2. Okay, and then I'm going to combine these together, so I'm going to end up with x divide 6 times divide 15 times is dividing 21 times. Okay, and I have a divide twice in the denominator, and I have my exponent on the outside that I have to keep track of. So here I'm going to subtract. So this is really divide, which is times. So it's going to count against that divide there. So I'm going to subtract 21 minus -2, which is +2. So I get x to the power -19 to the power 2. So I'm going to square this, power to power. I end up with x to the -38 as my final answer. Okay, so this is, I'm just kind of applying the exponent rules. I do have to be very, very careful of my negatives and positives though. Okay, when I do this, I have to be very concise with what I'm doing. Otherwise, one little mistake, it's going to be all wrong. So I can do the same problem with a slightly different strategy. And what I'm going to do is I'm going to, again, work from the inside first. But I'm going to apply the negatives, and I'm just going to deal with these negatives first. Okay. So these negatives really mean that I have negative, this is my base. That represents my whole base. And I'm going to divide by that base 3 times. Well, that negative really means divide. So all I'm going to do then is I'm going to use that divide and put it into the denominator where it belongs. And so that negative power 3 ends up as a positive power 3 in the denominator. And I made a little mistake here. That should be, I was kind of jumping ahead. That's going to end up being power 7, but that's going to, for now, it's power 3. Power 5. Okay, so there's I dealt with the negative power as the division statement. And I'm going to do the same thing here. That's a divide in the denominator. Well, divide in the denominator really works out to be times in the numerator. Okay, so that's going to be my power 3, and then the extra x I'm going to put over here. So now all I've done is deal with the divide 3 times, so it's power 3 in the denominator, divide 3 times, so it's power 3 in the numerator. And then I can just going to count it up. So I have x cubed, x to the power 7 to the power 3, and then an extra x here, all squared, x cubed, x to the 21 times x. So I have 3 multiplies, 22 divides, so that means I have an extra 19 divides. So I'm going to write that as x to the power 19 in the denominator. And that works out to be 1 over x to the power 38 when I apply the square onto that. Okay, and these are exactly the same. That means I'm dividing by x 38 times. Here I'm dividing by x 38 times as well.